Hello everyone, my name is Santiago Lamasa and this is my astronomy project, ExoPlanets. Now, you're probably wondering, what are exoplanets? Well, basically, they're any planets that orbit outside of our solar system. However, they're always around near stars, and the ones that orbit freely as they choose are called rogue planets, which are found in galactic centers and untethered to stars. It's not easy to find exoplanets. It takes years for astronomers to find them. But either way, the first people who got to discover the first two exoplanets were known as Alexander and Dale Frasil. The two exoplanets that they discovered are located in a pulsar called PSR 1252 plus 12. When the astronomers discovered the shape of the exoplanet, the form is not exactly what they were anticipating. There are 5 methods that can be used to detecting exoplanets. The first one is astrometry, to detect planets by knowing where the star's position is located in the sky. However, this method can also be used in finding exoplanets by measuring the star's position as it wobbles around the central mass of the planetary system. Method number 2 in detecting exoplanets is Doppler spectroscopy, the method that is used to detect the planet's velocity shift of the stellar spectrum. The third method is called transit observations, or monitoring spectrum, a method that is used when a planet passes in front of its star as it overly slightly starts to dim its light. In other words, it's the stellar spectrum of a star as it starts pulling on its star, causing it to subtly Doppler shift. The fourth method is known as microlensing, a method that uses a network of telescopes that specialize in looking for any signs of the presence of a planet. The last method to detect exoplanets is called direct imaging, a method that directly captures images from a planet. Thanks to the light being reflected from the exoplanet's atmosphere in infrared wavelengths. These circumstellar disks are called protoplanetary disks, which are very difficult to observe since the stars they surround are 100,000 times more brighter than the disks. These circumstellar disks are called protoplanetary disks, which are difficult to observe since they surround stars which are 100,000 times brighter than the disks. If you're wondering why it's important to learn about exoplanets, it's because it helps us understand the processes that the universe goes through, so that we may better understand if we can find planets out there in the universe that people don't normally see, like they're in front of stars or the stars themselves that are blocking the planet itself. Exoplanets are made up of elements similar to that of the planets in our solar system, but their combinations of those elements may differ. Some of these planets may be dominated by water or ice, while others may be dominated by carbon or iron. The categorization of the exoplanets represents what makes them so interesting. Like, for example, they can boil. The categorization of exoplanets represents the interesting facts about them. Like, for example, they can be hot enough to melt metal or be locked in deep freeze. They can orbit a star so tightly that 1 year will only last like 2 days for them, and they can orbit 2 suns at once. For an exoplanet to be able to sustain life, it needs to orbit near the habitable zone, so that the surface is just the right temperature for liquid water to exist. Since the life that we know needs water to survive, if the exoplanet is too close or too far from its host star, then the less its chances are to sustain life. Today, 5,000 exoplanets have been discovered and are considered confirmed out of the billions in our galaxy alone. The word exo means extrasolar, meaning away from our solar system. The name exoplanets was given to by the International Astronomical Union, also referred to as IAU, through public naming contests called Name Exo Worlds. As of June 2021, a total of 59 potentially habitable planets have been discovered. For any exoplanet having a whole star would mean being drowned by its radiation. And, well, that's it for my project. So thank you everyone for giving me another chance, for doing the best you can for me, and goodbye. I end my presentation.